Hi, this video is going to be looking at atoms. Atoms are tiny particles that make up every item in the world. We have a diagram of an atom here. Atoms are made up of 3 subatomic particles. One subatomic particle is protons, and these are found in the centre of an atom. They have a mass of 1 and they are positively charged. On the diagram, they are the blue subatomic particle. We also have neutrons. These have a neutral charge and they have a mass of 1. Neutrons are also found in the centre of an atom. The final subatomic particle is electrons. These have a negative charge and the magnitude of the negative charge is the same as protons but in the other direction. The mass of electrons is so small that we say that the mass of an electron is 0. Electrons move around the nucleus in shells, and we're going to be looking at shells later on in this video. So protons and neutrons are found in the centre of an atom, and the centre of an atom is known as a nucleus. The nucleus is tiny in comparison to the size of the rest of the atom. Then the electrons move around the nucleus in shells. Electrons are much smaller than protons and neutrons, and this is why the electrons have a mass of 0 and the protons and neutrons have a mass of 1. Atoms should have no overall electrical charge. They should have the same number of electrons as they do protons. And as electrons and protons have the same magnitude of charge but in opposite directions, an equal number of electrons and protons would mean that there is no overall electrical charge for that atom. If some electrons are added or removed, the atom becomes electrically charged and is known as an ion. A substance that is made up of only one atom is known as an element. There are over 100 different elements. Elements are represented by 1 or 2 letter symbols. This makes it easier and quicker to write out formulas and chemical compounds. It is the number of protons that determines what type of element an atom is. All atoms with the same number of protons are the same element. For example, all hydrogen atoms have 1 proton, and they have the symbol H. All carbon atoms have 6 protons, and they have the symbol C. It is only the first letter of the symbol that is capitalized, and the second one must be lowercase. For example, if we look at helium, it has a symbol of He. So the H is capitalized and the E is in a lower case. So now let's have a look at electron shells. These are also known as energy levels. Electrons travel around the outside of the nucleus in shells. Shells are only able to hold a specific number of electrons. The first shell holds a maximum of 2 electrons, the second and third shells can hold 8 electrons. An electron will always want to fill the lowest energy level, i.e. the closest shell to the nucleus. When the shell is full, electrons will start filling up the shell just outside the shell that is full. Shells do not have to be full, and most elements have their outer shell partially filled. The periodic table shows all possible elements. It is laid out in a special way so that the columns and rows tell us certain characteristics about the element. The rows signal how many shells are in use. So elements in row 1 have electrons in their first shell and no electrons in any of the outer shells. Elements in row 3 have their first 2 shells completely full with electrons, whereby there is 2 electrons in the first shell and 8 in the second shell. They also have some electrons in shell 3. The columns on the periodic table show us elements that have certain characteristics. All the elements in group 1, which is the first column on the left, have 1 electron in their outer shell. As they have the same number of electrons in their highest energy level, they react in the same way. Group 1 elements react with water to form hydrogen and an alkaline solution. Also, they will react with oxygen to form an oxide. Group 1 and Group 2 are known as the reactive metals. The elements in the far right column have full outer shells. These are known as the noble gases and they are stable. The noble gases are stable and unreactive because they have a stable arrangement of electrons, whereby the outer shell is full of electrons. So to summarise, the row tells us how many shells are in use, and the column shows us the characteristics of the element. The periodic table also gives us the mass number of elements. The mass number is written in the top left corner, and the number of protons is written in the bottom left corner. The mass number is the number of protons and neutrons in an element. Therefore, we can work out the number of neutrons in an element by subtracting the proton number from the mass number. So here we have carbon. We've got the mass number, which is 12, and this is in the top left-hand corner, and we have the proton number, which is 6, and this is written in the bottom left-hand corner. So this tells us that carbon has 6 protons. To find out the number of neutrons that it has, we do the mass number minus the number of protons. So we do 12 minus 6, and this tells us that carbon has 6 neutrons. An element will be neutrally charged, and this means that the number of protons that the element has will be the same as the number of electrons. Therefore, carbon will have 6 electrons. It will have 2 in its first shell, and its first shell will be completely full, and then it will have 4 in its second shell. So if we were to draw a diagram of what our carbon atom would look like, we would have the nucleus in the centre, which would have 6 protons and 6 neutrons. We would then have 6 electrons. There will be 2 electrons in the first shell and 4 in the second shell. We are indicating electrons on the diagram by the little crosses, and the shells are indicated by the circles. In the exam, you are expected to be able to draw out any of the first 20 elements. In order to do this, you need to follow these steps. The number of protons is the number of electrons, and this is so that the element has a neutral charge. The first shell is made up of 2 electrons, and then the next 2 shells are made up of 8 electrons. The final key piece of information to know is that we find out the number of neutrons by doing the mass number minus the proton number. For more videos, content, quizzes and past papers, go on to www.elevise.co.uk.